Good afternoon. This is Annette Oso, and I'm welcoming you to the first webinar of the 2024 Fall Resiliency Academy series. As folks are coming in, we'll be doing a few introductions and logistical notes. Again, my name is Annette Oso, Managing Director for Resilient Virginia. And I want to thank my colleagues, Trish Porter and Ann Whitlow, who worked on planning these events. And in addition, Jerry Cervenka, our technical advisor, who's assisting with production today. On the technical side, we want to note that we are recording this session and sharing the slides of the presentations with attendees. You are going to be on mute during this time, but are certainly welcome to add your name and introduce yourselves through the chat. And also, please add your questions for presenters in the Q&A box. We'll be addressing those questions in a discussion period at the end after the speaker's presentation. Finally, note that the transcription feature is enabled if you would choose to use that. The Resiliency Academy series began in 2020, and we've taken on a variety of climate resiliency themes each year. This year, we've been able to focus on a very timely topic, which is the integration of climate concerns in hazard mitigation planning. The first fall session today sets the stage for the next 3 webinars, where we'll be introducing the FEMA's requirements and new programming related to including climate in hazard mitigation plans. We'll bring together some tools and resources, including those coming out of the Mid-Atlantic RESA organization for developing your local plan, and we'll feature some local and regional examples of hazard mitigation planning that also have included climate impacts. You see the agenda for today, and we will start off again while some additional folks are coming in with a quick poll to give presenters an idea of the sectors that are represented by today's attendees. So the poll will start up now and be up for 30 seconds. Please do respond. Let's look at what the poll says. Here we've got some fairly even representation, local government, nonprofits, and businesses, and then some from academic, community organizations, state and regional government. So thank you all for that quick look at the attendance in the sectors. We want to, before we go forward into the speakers, thank our Resiliency Academy sponsor, Mid-Atlantic RESA, which has gotten funding, has funding through NOAA to support what we're doing, what we have done in the spring, and now our Fall Resiliency Academy series. And we want to thank them for allowing us to both highlight what they're doing to assist localities and bringing in other speakers from around the region. In addition, we'd like to recognize the support of our current annual sponsors, with those folks, as well as our government, institutional, and individual members and general donors, we've been able to bring a wide range of resiliency resources and educational events, such as the Resiliency Academy, out to the Virginia communities, as well as to bring to you all our biennial conferences, which we'll be talking about at the end as coming up next year in 2025. I'll go through a brief set of bios of our speakers today, and then we'll hear from the various speakers. First, we'll have Dr. Jeremy Hoffman. Currently, he is the Director of Climate Justice and Impact for Groundwork USA. He was also the lead author of the Southeast chapter of the 5th National Climate Assessment, which provides us with the latest information on projections for climate impact in our region. He's also affiliated with the Virginia Commonwealth University and University of Richmond, and has been for a number of years now a recognized climate science communicator in this region as well as nationally. Next, we'll have Art DeGaetano, Professor of Earth and Atmospheric Sciences at Cornell University. He has been involved with climatology since his PhD at Rutgers back in 1989. So when he joined Cornell, he is of course a professor there, as well as the now the director of the federally supported Northeast Regional Climate Center. Also contributes to the American Meteorological Society journal. So we appreciate his involvement. Our third speaker will be Jessica Whitehead, again, a professor at Old Dominion University and executive director of the Institute for Coastal Adaptation and Resilience. She is the lead author of the Northeast chapter of the 5th National Climate Assessment. So we really appreciate these folks with a lot of background and knowledge being involved today. She is a member, of course, working closely with the Virginia Coastal Resilience efforts through the Technical Advisory Committee and also through all the programs that they're doing out of Old Dominion University. Previously, she was the first Chief Resilience Officer in North Carolina and involved in various ways in resilience work in North Carolina. Finally, we will have an overview of what's happening in Region 3 through Rodney Bahner's presentation. He's a community planner for FEMA and works out of the Virginia FEMA integration team right here in out of the Richmond area. So we are pleased to have a whole set of FEMA folks actually working now in Virginia. Previously, he worked in land use planning and historic preservation out of Morgantown, West Virginia. So he has a master's degree out of University of Oregon. So those are our speakers. We're really looking forward to their presentations. Before we get started, we wanted to ask folks to tune in, give us a little feedback through the Mentimeter process on let us know what you all see as impacts of climate in your area. So you can either click on the QR code on the screen or there is a link in the chat that you can go to, and we'll record your responses here for just a few minutes and end up with a word cloud here that we'll be happy to share with folks. And here we're seeing the word cloud forming. Of course, flooding, and we know that flooding is a major problem, as well as dealing with heat. This summer, we've had quite experience with intense heat and drought conditions in a variety of parts of the state, which has affected our farm communities and our communities in general, our water supply. All right. And we will share, of course, this information again through our website and let folks know the end result there. Trish, as I understand it, we're launching into our speaker presentation. So let's do that now.
Good afternoon, everyone. My name is Jeremy, as you heard. Thank you, Annette, for the introduction, and to your team for the invitation, and congratulations on retiring, Annette. I don't know if you know, that's very widely known. You've been at this for many years. You were one of the first people in Virginia to invite me along on different things. I really wanted to make sure that I said that how important you've been to starting my career off on the right foot here in Virginia. So thank you so much, Annette, and yeah, I hope we can connect before you are off doing whatever it is you're planning on doing for retirement. So thank you. So as you heard Annette say, I'm the Director of Climate Justice and Impact at Groundwork USA. I was previously at the Science Museum of Virginia, where I did a lot of work on extreme heat. Now, I'm not going to go into like super detail about very high resolution kinds of data sets about heat exposure, but please do reach out if you're interested in learning more about heat mapping in your community, or constructing heat vulnerability indices and so on. I'm going to keep this at kind of a broad brush findings level from the chapter, the Southeast chapter of the 5th National Climate Assessment, which I'm sure, as you hear from Jess Whitehead in a talk in a little bit, you'll kind of see that even though Virginia is part of the Southeast, the Mid-Atlantic writ large has kind of the same kinds of patterns with relation to extreme heat. And so I'm just going to share with you some of the findings of our chapter. I'm going to pepper in some of the other stuff that's in the 5th National Climate Assessment. The website is nca2023.globalchange.gov. You can download all of the figures that you see in this talk with like one exception directly from the NCA 5 website and use them however you'd like. It's a really hugely important resource that is the kind of state of the science for US climate impacts right now. And as the, AR7, the next IPCC report is being thought about, and the NCA 6 has just launched, I think, as of today. The lead authors are getting put together. It's super important to just try and integrate this regularly updated national climate assessment into your day-to-day work. So again, encourage you to go and check that out. I was fortunate enough to be the lead author on the NCA 5 Southeast chapter with an absolute star-studded cast of scientists from across the Southeast. And people that were technical contributors. It's truly a work of many hands. And I'm super happy to be here somewhat, kind of reporting on this even almost a year after it was published. Now, this is one of the things that you can't get out of the NCA 5, but I thought it was super important to start off with this. You just heard that we've had a really rough summer with heat. Well, we've had the most heat-related illnesses in Virginia since the VDH has been tracking it, starting in like 2015. You can go and check out the VDH Essence website. And what I'm showing is a map of Virginia on top, converted into the heat-related illnesses per 1,000 or 10,000 visits. And the kind of pattern that shows up is not so much that the urban centers of the state have exceptionally high rates of heat-related illness, but really it's areas of the state that are more rural. This is not an unknown finding, but from work that was done in North Carolina and in Georgia, where we see actually a lot of our heat burden is being played out disproportionately in rural areas. Now, that story gets more complicated when we get into cities, which I'll go into in a little bit. But what I'm comparing these data to on the bottom is the CDC's own social vulnerability index. And just by seeing where the dark blue areas of high vulnerability overlap with areas where we have higher rates of heat-related illnesses this summer, it's pretty comparable. Now, this is a low, medium, high kind of designation versus different amounts of cases per 10,000 visits, but the overlap between areas of relatively medium, high, and high overlap for these burdens of heat-related illness are pretty stark and striking. So, we've known about these sorts of patterns for a long time, but we've seen no alleviation of the pattern. And if you still have the level of vulnerability predicting where we have negative health outcomes, we're not really learning or putting into practice yet the sorts of things that build community resilience to extreme heat. So I've had the opportunity to publish a lot of things on cooling centers, on heat-related emergencies. So we're still not putting into practice the things that researchers and practitioners have been saying for years. So I would encourage you to look into these data sets that we have for the Mid-Atlantic and especially here in Virginia to learn more. Now, this is figure 1.1 from the NCA. Extreme heat. A person born in 2020, like my niece Riley, could see as many as 5 times the number of extreme heat events. You can see over here in the top right corner, all manner of different types of climate events are expected to get worse depending on the total level of global warming. But heat waves stand out far and away as the thing that could get the most intense as compared to the present. So someone retiring in this decade will have seen 5 times fewer heat-related events than someone born this decade. And I think that kind of intergenerational aspect to this is really important to put out there, because entirely in our hands is how much warming ends up happening. All of these climate scenarios are predicated largely on an uncertainty around what do humans do in the next decade or two with respect to climate emissions. So this kind of intergenerational burden of the integrated impacts of global warming and climate change disproportionately fall on young people that are being born right now, but are largely the responsibility of those who have come before us. So I encourage you to think really deeply about what that kind of disparate impact on your subpopulations in your jurisdiction look like. You know, if you have a lot of kids in a part of town, you know, those are the sorts of people that will have stake in your community, potentially when we see of intermediate scenario emissions. And the sooner we, you know, do anything, act in any capacity, the better case we have to limit the issues of the future. So just thought I'd like to throw that out there because it's something I like to reflect on quite regularly. Shaping heat risk is, of course, where populations grow and where they decline. Much of the growth in the Southeast and in Virginia has been in and around our urban centers. There's been population loss in a lot of our rural areas, and that pattern is largely expected to continue into 2050. That, of course, puts more people in places that are disproportionately affected by extreme heat. And you'll hear a lot more about things like coastal issues and so on. But superimposed on this growth pattern are patterns of like the social determinants of health that ultimately set our life expectancy. You know, your zip code tells me a lot more about your life expectancy than what you do on a day-to-day basis with your own personal health. And this is also reflected in our patterns of social vulnerability, which I showed before in Virginia, disproportionately falling kind of along that southern edge, southern border along with North Carolina. And when it comes to extreme heat, these particularly vulnerable areas and people tend to be bunched up in places where we're going to see, or we're expecting to see, the largest projected change in extreme heat days by the mid-century. Now, on the right, that's a map of those changes in extreme heat days in 2050 related to the last 30 or so years. And that's under a medium, you know, kind of intermediate emissions scenario. So this isn't worst case scenario warming. It could get a lot worse depending on how much more we choose to emit. But this is kind of the main trajectory that we're on right now. Now, this extreme heat days aren't the only thing that we care about when it comes to heat. Of course, hot days on the left, that's really important for things like infrastructure, public health, but also the heat or lack of heat in our yearly annual cycle, as the middle panel here represented by cold days. So across the mid-Atlantic, we're going to see, you know, as fewer cold days on average. Now that means a lengthening growing season. That means worse allergy seasons. That means more complicated timing for harvest and pollination. And then on the far right, it's not just the most extreme temperatures during the day that are changing. We're also seeing, I potentially could see a massive change in the number of warm nights, these kind of tropical nights where we add more and more cooling need and kind of energy capacity or energy burden over the course of the evening. Now, superimposed on these kind of large-scale patterns of climate-related warming, we also have development patterns that can either exacerbate or dampen extreme heat at the same time. So these are maps of cities from around the country, but Atlanta here in the Southeast, showing that from 1985 to 2020, there was a significant expansion of developed land cover. In fact, the Southeast has the most land that went from forested to developed over that same time period. Something close to 2 million football fields worth of land went from forest to developed. Now, as you know, those kind of developed land, urbanized land types absorb and then re-emit more of the sun's energy than their native and local vegetation. So we actually have warming associated with those areas that are largely built out, largely dominated by buildings and road materials by several degrees. And this we can see kind of expanding across these same cities. So over time, as you expand that kind of urban bullseye, you get an attendant increase in that land surface temperature related urban heat island effect, as it's known. Now, something that I've helped to understand in a historical perspective is how these urban heat islands, so pockets of places within cities that further amplify background warming, is that they're associated with poorer and communities of color, largely across the country, but definitely from within Virginia. And this is locked into a history of marginalization through urban planning policies like redlining and urban renewal. So we can tie together the subpopulations in our communities that are disproportionately exposed to extreme heat and who ultimately then are borne out in our public health related outcomes. Now, there's also some infrastructural related things that are going on here, as the direct relationship isn't particularly clear, but we do have evidence that there have been an increasing and an increasing number of warm season related energy blackouts. So these are blackouts that affect more than 1,000 people for more than an hour. If you don't have air conditioning in the South during the summer, and largely that's going to continue to expose more of the northern latitudes as well, that may never have had air conditioning. If you have a loss of energy or power and you don't have air conditioning, that will drastically increase the risk of heat-related illnesses and risk for residents, especially those of vulnerable populations at the same time. Now, we know that the ability for our communities to actually adapt to these changing conditions and risks is directly related to their capacity. Do they have a functioning city governance system that has money available and resources to distribute to the most in need residents in a management kind of response to extreme heat? Well, that largely depends on where you live too. Much of Virginia, where we have areas of very high social vulnerability, we also have very low rural capacity, which is represented by the red colors here. Now, also across the Southeast, there's a history of this kind of legacy of if you're born into a poor family, you're going to remain poor yourself. And so where these places overlap, that means that there's very little chance for growth in the economics of the individuals, the residents that live there, and you're already at a very low capacity as a community. So these are the kinds of areas that we should probably be focusing on in near and long-term investment in climate resilience to ensure that they're even able to start to think about these issues. Now, heat doesn't just affect people in our public health, it also gets in the way of our infrastructure. More and more we're seeing during the summer examples of roads buckling, delays on Amtrak from needing to slow down because the passenger rail is warped because of the temperatures during the summer. And so what we found in our chapter was even under an intermediate warming scenario, we could save billions of dollars if we just were to proactively adapt, and that disproportionately benefits our road networks, which have only so much kind of heat related stress and strain that they can take. This is also true about our electrical grid. So we talked about those blackouts. Now, we can't tie that necessarily directly to lack of investment in adaptation. However, looking into the future, some of the things that will befall our energy grid are largely tied to the effects of regional warming. And so same like our transportation networks and shipping networks, we save a lot of money, probably double by investing in proactive adaptation to electrical grids across the Southeast. The number here in Virginia is, double. So we save, hundreds of millions of dollars per year. And so, yeah, that would be really good to think about. Now, we're not just talking about places with infrastructure. We're also talking about places with have much more of an agricultural kind of background, of course, associated with more extreme heat. and a thirstier atmosphere are the risks of things like flash and long-term severe drought. That already is affecting communities that have higher proportions of farms that are owned by Black farmers. So we can't escape the history of our region and largely the country itself having this legacy of marginalizations, particularly along poor and communities of color, bearing and the brunt of climate change impacts across a variety of different sectors, including agriculture. So that's all I have for you today. Like I said, there's a bunch more about getting into finer scales at smaller and smaller parcels. So that, you know, reach out if you want to learn more about extreme heat at the hyper local scale. I do a lot of that work. It's Jeremy at groundworkusa.org. Thanks again, Annette, for the opportunity, and I'll stop my share.
All right. Thanks so much, Jeremy, and thanks for your note about the future of myself and the organization. So there are themes to these various speakers that I did not clarify, but Jeremy was obviously on the heat side of things, and Art will speak about precipitation, extreme precipitation. Jessica Whitehead will focus, of course, on the coastal area. And then Rodney will give an overview of the region. So with that, I will invite Art to go forward then. Thanks.
All right, and I assume my screen share came through okay?
Yes, it looks good.
All right, and boy, being the northerner on this call, I am glad I live where I do, following up Jeremy's talk. So we're going to switch from the hot to the wet and speak of some work that we've done in Virginia in the mid-Atlantic states, particularly related to extreme rainfall. This is work we've done with our colleagues at MRISA, the CAPRISA program that is down and covers your states. So I think Jeremy did a good job of kind of hitting my introduction slide as why climate matters. You know, across the nation, not just in the southeastern Virginia, we're seeing an uptick in the number of extreme weather events, climate disasters that cause a significant amount of damage and come with a substantial cost. We look at the insert at the bottom right, what we see is many of the increase we've seen through time has to do with things like flooding and severe storms and tropical cyclones and all. So that speaks directly to the impacts of extreme rainfall. So if we kind of look at extreme rainfall through time, these are averages from NOAA's National Environmental Information Center, NCEI. This is averaged over the state of Virginia. It's pretty much the longest term data set that we have in the US. And what I'm showing here is the total rainfall in a given year. So we're not really looking at extremes in this case. And I guess if you focus your eyes on the blue line, that shows the trend, where back in the late 1800s, the state of Virginia averaged just over 40 inches of rainfall in the year. And now if we look at the current period of time, we're up to about a little over 45 inches in a year. So in round numbers, about a 10% increase over this a little over a century. If we look at how this has changed through the season, I think this presents a more interesting picture and actually speaks a little bit to what we're going to discuss with the extremes. So I'm really showing, winter, spring, summer, fall, as you can clearly see. We're talking about the meteorological seasons. So they're months. For example, winter would be December through February. And really, if you kind of, again, focus in on those blue lines, I think you can notice the trends are more pronounced, particularly in the fall across Virginia, and to a certain extent, the spring, so what we might call the transition seasons. Winter, the trend is increasing, but very, very subtly. So I have only a small trend through time. And then if we look down at summer, the trend actually operates in the opposite direction. We actually see a decrease in summertime precip across the state of Virginia. And this will have implications not only for extreme rainfall, but what we might see in drought. So kind of the the precipitation talk does go hand in hand with some of the things that that heat impacts. So one measure of drought is the Palmer Drought Severity Index. So again, from that same database from NCEI, we look at that index. This is on actually a monthly basis through time, so the bars are pretty narrow. If you focus in, the yellow bars that point downward are pretty much drought periods, so that's when this index is negative, and the green bars represent wetter periods when areas are not in drought. And if you look at that graph, you might, especially if you focus in on, say, the 2000s, you probably see less drought than you've seen historically across the region. But nonetheless, these droughts are still occurring. And kind of the same thing with rainfall. You definitely see these wetter periods showing up pretty much from almost 1960 to the present. You see many more green bars and many higher Palmer Drought Severity indices that indicate wetness. That this doesn't say that there is no need to worry about drought. And I think, as we'll see, drought is really taking on kind of a different picture. We're seeing a lot more of these kind of short-term summer droughts. Jeremy mentioned flash droughts. These are droughts that come about pretty quickly. And we're seeing things like that across much of the eastern United States in current years. And also the rainfall patterns also kind of factor into that as well. What we'll see is across the region, we're seeing many more intense rainfall events where it rains much heavily. Much of the rainfall comes within an hour or two, as opposed to being spread across the day. And rainfall such as that tends to run off, so there's some indications that it's not as effective at eliminating drought conditions, replenishing soil moisture and such. Okay, so if we look at some work we have done with Marisa as part of their CHAMP, Climate and Hazard Mitigation Planning Tool, what I'm showing here, I'm focusing down on Virginia. I am looking at trends in rainfall. So these are trends in precipitation. Basically, anything that is green is an increase in precipitation through time, and the darker the green gets, the more pronounced the trend is. So here we're looking at total annual rainfall, and the color coding here is in inches per decade. So really, in these lighter greens in through northern and in some cases south central Virginia, we're looking at about a 10% about a 1 inch increase in rainfall per decade in these areas. And then as we move into some of these darker green areas along the coast and in the mountains, these are more on the order of 2 or 3 inches of rainfall increases per decade. This is the same tool, but now I'm going to kind of shift gears and look at more extreme rainfall. So on the left, we're looking at days that have more than 1 inch of rainfall. And to the right, we're looking at days that have more than 2 inches of rainfall. This is the trend since about 1981 to 2023. And again, I think the things to note is really that same type of a local pattern where the largest changes in these, I'll call them extreme, but you may argue with me they're not all that extreme, 1 inch of rainfall in Virginia, are occurring in the western part of the state and also along the coast. And actually in through central Virginia, the trends are somewhat less. These darker green areas in counties, again, to the east in the mountains, are on the order of getting 2 more of these 1 inch rainfall days in a year per decade. And then to the right, same type of graph, but now we're looking at 2 inch rainfall events. Same type of pattern. So we might say here in southeastern Virginia, what we're seeing is an additional 2 inch rainfall day per decade. So in the last 30 years, we've seen 3 more of these days in coastal areas of Virginia. Most of our work has factored into, I would say, more extreme rainfall events. So these are the types of rainfall events that really start to factor into infrastructure design and such. So up at the top, we're looking at rainfall amounts that have a 2-year return period. We would expect on average to see an event like this occur once every 2 years. So any year has, basically a 50% chance of having one of these rainfall events. And down at the bottom, a more extreme rainfall event. This is the 100-year storm. Any year would be expected for this type of rainfall to occur with a 1% chance. Or the other way to think about it is, on average, we would expect a storm like this to occur once every 100 years. And what I'm showing here is we've broken the recent record from 1950 into 2 equal periods. So they're about 36 years, 37 years each. And what's being plotted is the difference in that rainfall amount between the early period and the late period. We've looked at this at a number of stations across pretty much the eastern United States, east of the Rockies. And any one of the dots here that is green represents an increase in rainfall from the early to the late period. So if I go to the 24-hour precip and focus on that station in Virginia, that is the darker green dot, that's about a 40% increase in there. We're actually looking at the ratio of the 2 periods. So across much of Virginia, we're kind of in this range of, in the observed period, we've seen as much as a 40% increase in the 2-year storm. If we look at the 100-year storm, a more extreme event, kind of a little bit different picture for the 24-hour precip. You see some green dots and some small changes in the east, and actually some declines in the west for the 24-hour event. But if you look over to the far left, these are the hourly precipitation totals. So instead of looking at the 100-year or the 2-year storm on a daily basis across all 24 hours of the day, this is the intensity of rain that is expected in a 1-hour period. And quite striking across much of the Southeast, and particularly Virginia, that these 1-hourly events have increased quite a bit from the early to the late period. Again, changes on the order of 30 to 40%. In terms of urban infrastructure design and things like this, these are the rainfall events that really, really matter for flooding and inundating culverts. I saw in the word cloud early on things about culverts washing out. These are the types of precipitation events that are more attributable to that. Real quickly, the graphs on the far right represent how the hourly rainfall is changing relative to the daily rainfall. And really, the take-home message there is for the 2-hour storm, it's really the daily events that are increasing at a faster rate. But when we look at the 100-year storm, particularly across Virginia and up into my neck of the woods into New Jersey and New York, the darker colors there represent a bigger change in the hourly events than the daily events. And though I haven't analyzed the data particularly for Virginia, when we look at this across kind of the New York City metropolitan area, we see this pattern being very much attributable to the remnants of tropical storms and things like that. So we see a lot of these big events occurring embedded within tropical moisture that's coming up from your region. Kind of translate these rainfalls to hazards. Really, there's this is again coming out of the CHAMP tool from Marisa. We're looking at annual reported flood events across Virginia. And you can see a lot more events occurring here since about 2000. This is the best data that are available from NOAA in terms of actually looking at impacts from weather-related events. However, kind of the caveat here is there's a lot of reporting biases in these data sets. With the advent of social media and such, a lot more of these events get reported in the more recent period than they did back in the 90s or even before. So there's some artifact of that in an analysis like this. Let's kind of switch gears and let's look to the future. So first thing, I want to at least put a little bit of context to this. Whenever I give a talk about impacts or resiliency and things like that, most people are interested in, oh man, how can we, what is climate going to change due to thunderstorms or to these intense 1-hour rainfall events and things like that. And the thing that I want to point out here is in this graph that actually came out of a series of papers looking at climate impacts, we really start to look at these fine scale phenomena that cause a lot of impacts: hurricanes, tornadoes, strong winds, even to some extent floods and droughts. Really here are the connection between these events and climate change is kind of a couple of steps down the road. Climate change is clearly and has a very direct effect, and we can point to the physics of why it affects things like average rainfall in hot days and cold waves down and things like that. And our database of these changes through time is quite high, or actually quite robust. But as we move into things like short-term intense rainfall, hurricanes, even floods, we kind of move down, and there's more things that can change in terms of, there's more things that affect these changes in the landscape. It's not just climate and things like that. So wanted to kind of put that out as a caveat. And also the second caveat is a lot of the data that we're going to discuss, a lot of the projections really depend upon what we as society do. So it's really what pathway we're on. Jeremy spoke to that a little bit in his talk, and he said a moderate scenario. So I'm assuming he's choosing this scenario, which is called scenario 4 on this graph. And this is a graph of our carbon emissions. So basically, we're not looking at this very extreme case, which is really if we continue to what we are doing now, kind of business as usual. This more moderate case starts to bring in some of the programs that curtail carbon emissions that are being enacted politically. And then we'll see a number of scenarios here where we actually start to ramp down our carbon emissions. So I don't think any of my graphs talk about these, but they definitely talk about these two more extreme scenarios. So again, if we look at the CHAMP tool, the CHAMP tool will also let us look at some projections into the future. So I'm starting off with this very high emissions, this business as usual scenario. I'm looking at average precipitation. And if you look at that graph, you might say, Art, well, not much is changing in that graph. That's the average of about 30 models is shown in the black line. And that black line doesn't change much through time. And that is indeed the case if we're looking at average rainfall. You should note, however, that early on, around now, these data show something below 50 inches per year. But as we move out through time, again, most of these values are right around 50 inches per year. So there is a subtle increase in this through time. The blue shading on this graph and actually on some of the next graph shows the range of the models. So again, we're looking at 30 or so models. And in this case, some of the models are showing that by the end of the century, or actually even more by the middle of the century, that observed rainfall that we talked about, which is right around 45, may be as high as 65 or 70. So where some models are keeping this kind of status quo, others are increasing it quite dramatically in the average. If we look at rainfall days above 1 inch and rainfall days about 2 inches, again, there's a subtle trend in these graphs, but I would argue more of a trend that we saw in the previous graphs. For the number of days with more than 1 inch of rain across the state of Virginia, in the current period of time, right at the beginning of these model simulations, we're around 8 or 9 days on average. And by the end of the period, we're more up around 11 or 12 days on average. So an increase there of, about 20 or 30%. And the same thing here with the number of 2-inch days. Kind of here in the early period, we're around 1 day. And as we get out to the end of the series, we're kind of doubling that, maybe even tripling that, kind of in the end of the period. This average number of days across Virginia with 2 inches of rainfall increases to about 3, where right now we're expecting it to be about 1. If we kind of look at this idea of the 2-year storm, this is also coming out of some work we've done with our colleagues at Marisa. And what we're doing here is most designed for extreme rainfall is based on a NOAA Atlas called NOAA Atlas 14. The data in NOAA Atlas 14 ends in about the mid-2000s, probably about 2006, I believe, in Virginia. And what we're doing here is saying, all right, since most people are using these values to develop their resiliency plans, to build their infrastructure, really what we wanted to see is what would those values look like, not in the historical record, and Atlas 14 is strictly historical, but how might that look in the future with climate change built onto that? So here I'm looking at the 2-year storm. I'm looking at a period of time kind of centered on 2050, and I'm looking at a very high emissions scenario in this case. I don't know why I picked Franklin County in Virginia. I guess it's kind of in the middle of the state. And what this shows is that this value that we're designing the 2-year storm on now will increase by about 13% as we move to mid-century. Again, that's the median of about 30 models. The extreme range of those models, it could increase by about 25%. Again, the entire state is green, indicating a change of about 10%. If we look out to the end of the century, so now something centered more on on the latter part of the century, and my slide is wrong. This should be through 2099. We see a lot of blue come out across Virginia. And again, this looks like more of about a 20% increase in this 2-year storm that we see. So basically, whatever the 2-year storm would be now, probably in Virginia, something on the order of 3 inches, you would have to take that and increase it by about 20%. If we look at the 100-year storm, we see a similar increase of about 20% across the state. So here again, the 100-year storm in round numbers is probably something like 10 inches, and we need to add 2 more inches in that. So what we would expect to be a 10-year event to occur once every 100 years, we would now have to expect a 12-year event to occur once every 100 years. We kind of switched that around. That 10-year storm that we expect once every 100 years really drops down, and we would expect that to occur maybe once every 60 or so years in this regard. So a big change in the frequency of these events. Again, moving out to the end of the century now, that storm increases further, almost 25% increase. And in these very bright blue counties, some of them up in Northern Virginia and many along the southern border, these are changes as much as 30% on average in the storm. So that 10-inch event becomes a 13-inch event. We use a lower emission scenario and kind of go out to the end of the century. Really what happens is things flatten off. We don't see much of a change. There's still a memory in these systems. And although the change factors, the inflation factors drop a little bit, they're still quite high on the order of 20 to 30%. And then kind of as my last slide, the work we've done with Marisa in looking at that, we're based on actually an older class of climate models. The projections and the downscaled data that allow us to make these projections on a county level are just starting to come out now. So really, we're due for an update of our atlas to look at those change factors. But kind of as a prelude, what I'm showing here is some work we've done, again, up in the New York City area. So these are values for Central Park. And it's still, I think, a pretty consistent picture, at least across the region. And the way to look at that is showing return periods. So these are the 2-year storm to the 100-year storm across the bottom. These change factors, the ones that I was plotting for Virginia, are shown by the thick yellow line. And if you notice, they're similar to what I was showing to Virginia. This is the 2-year storm, on the order of, 15 to 20%, pretty consistent across here, across all return periods. But then focus on the red line. This is when we update these statistics using the new generation, the CMIP6 generation of climate models. It's very much the same greenhouse gas emissions scenario. These are analogous. But what we see, instead of averaging about a 15% change through time, we're really averaging about a 25% change in time. So the newer models are making the newer models and the newer downscaling techniques are making these changes in extreme rainfall more extreme than they were using the older generation of models by about 10%. So I think that's where I want to end. And again, yes, it does snow up here and a typical winter scene of campus here at Cornell.
Art, I just wanted to say thank you and appreciate your recapping for us the in-depth work you've been doing with Maurice. So Jess, we'll ask Jessica Whitehead to go forward now.
All right, thank you, everyone. And as I get started, I wanted to drop a couple more links here into the chat ready to go. I'm Jess Whitehead. I am with the Institute for Coastal Adaptation and Resilience at Old Dominion University. I was also the lead chapter for the Northeast. And those of you in Virginia may be thinking, why the Northeast? If you haven't noticed, the regions in NCA split the Chesapeake Bay in two. Part of the Chesapeake Bay stays with Virginia in the Southeast. The rest of it is all DC, Maryland, northward. And so the Chesapeake Bay ordinarily, by practice in the National Climate Assessment, gets addressed in the Northeast chapter because it's got to go somewhere. That said, today, Annette had a lot of things that she wanted me to cover. So I don't stick just to the Northeast chapter in NCA 5. I framed it a little bit differently. Hopefully it also mixes that up a little bit for those of y'all from Virginia who saw the talk in the spring. But I wanted to talk very specifically, because I know we're short on time and we want to have time for questions and discussions about sea level rise in particular, because this is the big driver of our concerns in coastal regions. If we look actually to the coastal chapter of the National Climate Assessment, I popped that link in the chat a bit earlier. One of the things, and these are slightly different scenarios than as Art was just talking about the SSPs. These go back to the NOAA scenarios that were in the 2022 Sea Level Rise Technical Report. So these scenarios are still tracked to the old RCP scenarios, and they're a little bit different. But nationally, we're looking at about an 11-inch rise along the US coastline by 2050. So that's nationally, that's not just the mid-Atlantic. But what we see after 2050 is that that's really when we start seeing some bigger variations regionally. One of the places where that variation is going to be higher than a lot of areas is the Atlantic coast, but the highest is going to be the Gulf Coast. So if we're thinking about our and I'm just going to say it because I've also been on the practice side. If we're thinking about how to get funding for programs that address these, because you're all here, I'm sure that you're all super interested in the science, but you all are really interested in how you can get money to do things about it. That's what the hazard mitigation conversation is going to be about in later academy sessions. Then the Gulf Coast is going to have a really strong case here. So thinking about how to do things along the mid-Atlantic becomes even more important. We also see under that intermediate scenario, predicted shifts in tidal frequency with minor, major, and moderate coastal flooding frequencies increasing. So what does this look like? If you're elsewhere in the Mid-Atlantic, the NOAA Sea Level Rise Viewer is probably one of the better tools that is available for you use. There are other tools like the Climate Central Surging Seas Risk Finder tool that you can take a look at. There are also now a number of private sector products. Each of those has pros and cons. I like to point people toward the NOAA tool first, because you know that it really has been vetted and is coming from a reputable source. So taking a look, kind of Maryland, Delaware, a little bit of New Jersey, not as far north as you are, sorry. What we see as we move forward from 2020 to 2040, 2060, and really I'm sticking these dates on here. They're kind of approximations. If you haven't noticed, the NOAA tool doesn't exactly tag these to dates based on those scenarios. It goes by increments. So 1 foot of sea level rise, 2 feet of sea level rise, 3 feet of sea level rise, and then 4 feet potentially by the end of 2100 as what we could be looking at for inundation. The nice thing about NOAA doing it this way is if you're interested in what surge looks like, you're not necessarily locked into a particular date of sea level rise. If you know you're worried about, I also want to use this to take a 3-foot look at what storm surge might be, this gives you a pretty good approximation, but there are a whole lot of other tools that are available through your state agencies, through your emergency management agencies that can help you there. I wanted to specifically pull out, because the Hampton Roads PDC has done a really cool comparison of the 2017 NOAA sea level rise numbers and those 2022 numbers. And what we really see in terms of, and this is just the Sewell's Point gauge here in Norfolk, which is about 3 miles from where I am seated in my office, there's not a whole huge difference between the 2017 and 2022, maybe a little bit slower in that near term, particularly through 2060 in that 2022 update, and then seeing that much faster acceleration in that 2080 to 2100. If you take a look at the coastal chapter, there's a really good graphic that talks about some of the reasons behind this. For our regions, uncertainty in what are the Antarctic ice sheets going to be doing and how fast are those going to be melting, what does that look like, is a large component of this. Virginia's Coastal Resilience Master Plan, if those of you who are in Virginia, we have a really, really cool tool from DCR that is tagged with the Coastal Resilience Master Plan. I'm pretty sure it's going to be updated next year once the next phase 2 of the plan is out there. And it takes a look at taking some of these sea level rise scenarios, but also taking a look at how that changes the probabilities of certain return periods for coastal floods. So if you're used to hearing 100-year storm, that's the 1% annual chance. I personally prefer this wording than calling it a 100-year storm, because I've talked to way too many people who say, oh, we just had a 100-year storm. Doesn't that mean we don't get another one for 100 years? No, it does not. The probability resets basically in any one day. You could get a 1% annual chance flood today, and you could get another one next week. That's just the way that it works so the probability is a little bit more accurate. And it does tag this to dates, specifically looking at the NOAA intermediate high scenarios. So as we are looking at coastal Virginia, and I did cut off Northern Virginia because I kind of already included y'all in the Digital Coast tools that I shared. 2020 flood levels, right now what we see most of these areas that are those dark blue that have that frequent mean high water or 50%, so that 2-year storm, tend to be those areas that are marshlands, low-lying lands. We don't have a lot of stuff on them. But as we go forward into 2040, 2060, and 2080, that is when Virginia really begins to see a whole lot of changes coming up from Back Bay into Chesapeake, into Suffolk, into Portsmouth, into Norfolk, Hampton, Poquoson, the Middle Peninsula, Gloucester, Newport, Matthews County, assuming that we take no action. So this is a lot of land. What does this mean, though? Because exposure is not necessarily harm from something happening from this, right? If you live in a house that is at ground level, you are going to be far more exposed and experience a lot more harm than someone who has elevated a house 4 feet, 5 feet, 6 feet. So what does that mean? Consequence of this is that events that we're used to seeing in certain frequencies change as we are moving forward. So as sea level rises, you see those spring tides that we might see a couple times a month, the king tides coming up 3 to 4 times per year, major coastal flooding and extreme flooding that might happen once in a generation. Ultimately, as you add the sea level rise, shifts. And so that extreme flooding that used to be once in a generation might eventually become once every 2 to 5 years. That really, really changes the calculus that you're putting into it when you're thinking about damages and when you're thinking about the actions that you could take. I don't have a whole lot of time to talk about adaptations. That's a whole different talk. But again, thinking about these real flood frequencies then, as we go through that minor flooding, what we see a lot during these king tides now that is disruptive unless we also have a compound event and dump a whole bunch of rainfall on it, beginning to become more frequent, and those, moderate flood events also becoming more frequent than they were in the past. And if we look down, specifically looking at the intermediate scenario, we begin to see some of this flooding frequency changing, particularly in both the southeast and the northeast as areas that pop out. What does this mean, particularly if you are a state agency who works in coastal management, if you're a nonprofit, if you're a locality? This is actually from the city of Hampton. I really like this because it lays over what everything means in one place with a real picture. As sea level is rising, those leads to rising tides. You have additional storm surge superimposed on top of that. You also have rising groundwater tables on top of increased precipitation, on top of more runoff from adding more structures, more impervious surface in coastal areas, all leads to having a lot more water to manage. So if you've ever had somebody say, it's not the sea level rise, it's the development, it really is an all of the above kind of answer in terms of what's leading to the flooding that we see. This also has an impact on ecosystems and the critters that we care about. So focusing a little bit on the Northeast chapter, we talk in key message 2 quite a bit about these ocean and coastal impacts, particularly to ecosystems, because of the number of states in the Chesapeake Bay, Long Island Sound, Narragansett Bay, Gulf of Maine, who are very fisheries dependent. This is a large part of the economy of these coastal communities. It's a huge part of the culture of these coastal communities. Virginia actually has the 4th largest landings by dollar value in the United States in our fisheries. So a lot of money here, a lot of critters. Rising sea levels leading to coastal marshes beginning to transform into open water. Hard bottom upland forests beginning to transition into salt marshes, and even seeing inland areas where that groundwater table is rising, places that used to only saturate seasonally becoming permanently saturated, and seeing some of those inland swamplands start to basically die out and turn into snags. One of the reports that's been done here in Virginia takes a specific look at sea level rise in coastal Virginia in 2050 and begins to start trying to calculate a lot of what can be done. Check out floodingresiliency.org, the Commonwealth Center for Recurrent Flooding Resiliency. This is one of the spaces where you can find this. Basically up to, beginning to lose a football field of land about every 82 minutes. That's a lot. And even if that's not where a person is living, that's habitat loss, that's storm surge buffer loss. So becomes very, very important. We also see a lot of marine heat waves. We see these in the Chesapeake Bay. We see them in the Gulf of Maine. We see these increasing in frequency, particularly over time. Again, this is not necessarily climate change. This is not a climate change graph. It is just looking at the data from 1980 to about 2020 and seeing this real shift since the early 2010s and how many days that we have marine heat waves in the Northeast. Animals respond to this. So if you're somebody who depends upon some of these species, This is just an example from the Gulf of Maine because it's in the National Climate Assessment. You could point to rockfish. You could point to the fact that we now catch a lot more shrimp in the Elizabeth River and in Chesapeake Bay than we used to. We see these animals responding to these changes in the ocean by moving or by not necessarily thriving as much as they used to. That leads to fishing behavior needing to change. That leads to quotas needing to change. It's very difficult to change fishing quotas. A lot of challenges for these coastal communities that are resource dependent. But the good news is that the coast is taking action. An example of both the Southeast and the Northeast, and a lot of the framing in our Northeast chapter of the National Climate Assessment focuses not necessarily just on, I don't remember who asked the question, where are all of the maps for the Northeast? No, our team made a choice knowing that the Atlas, and by the way, we do have a word limit. We can't make a chapter too long. So knowing that the Atlas was also going to be produced this year and a lot of this data was going to be available, we focused a little bit more on that who's doing what and how are they doing it kind of piece. So what are the impacts? But what are a lot of the responses? So if you take a look at the Northeast chapter, there are a whole bunch of examples, even bleeding down into the Chesapeake Bay just a little bit, of different ways that different communities are taking action. From Philadelphia to Baltimore to New York City to Boston to inland area. You can really take a look at those state level and local level actions. And then also we talk a little bit about tribal actions as well. The number of tribes in the Northeast who are developing their own climate action frameworks and coming up with projects to address the harmful effects of climate change. But as you can see, Virginia has been a leader in the Southeast, historically behind only Florida. Florida's got a whole lot of disaster money to work with, so they've had a whole lot of projects to put forward. But then a whole lot of leadership in the Mid-Atlantic and the Northeast in terms of actions. So takeaways, the sea level is rising. For the moment, we're really tracking that NOAA 2022 intermediate scenario. Although note, if you are in the Commonwealth of Virginia, the state's Coastal Resilience Master Plan and the state plans for the NOAA intermediate high scenario. That's also where, if you're in one of our Hampton Roads jurisdictions, what the HRPDC recommends you use for planning benchmark. This is compounded with extreme events, so that increased coastal flood frequency, increased depth, losses of habitat, losses of buildings, and those shifting species of things that we like to care about because we like to sell them and because we like to eat them. But the good news is that adaptation is progressing. Didn't have a whole lot of time to talk about it, but there's now an increased support, not just from universities working with local and state governments, but an increasingly robust private sector providing climate services within the Mid-Atlantic and the Northeast who's available to help. So with that, I want to leave you with my contact information and pass it on to the next speaker so we have time for questions.
All right. Thank you so much, Jessica. And to wrap up the look at Mid-Atlantic, we've asked Rodney Bahner with FEMA to weigh in on how FEMA is looking at disasters and that sort of thing in the Mid-Atlantic. So Rodney, take it away then.
Hi, good afternoon. Thank you. My name is Rodney Bahner, again, a community planner with FEMA, based out of Region 3 and embedded with the Virginia Department of Emergency Management here in Richmond. The other presenters did a great job. I am not a doctor. I didn't even stay at a Holiday Inn last night. I will go through quickly a couple other things. They did a great job of covering the big parts of what we're seeing in the region. So just briefly, we'll take a look at the national picture. This is not the first time you've seen a slide, but this is a more updated version. So this is as of this is this year, 2024, as of August 8th. There have been 19 confirmed weather or climate disaster events with losses exceeding 1 billion. So this doesn't capture all of the disaster events, this is the major ones above 1 billion. These include 15 severe storm events, 1 tropical cyclone, 1 wildfire, 2 winter storms, and overall these events have resulted in the deaths of 149 people and severe economic effects on the areas impacted. And these disaster frequencies and impacts are only increasing. So between 1980 and 2023 or 2024, the average was almost 9 events, adjusted for inflation. The annual average for the most recent 5 years is almost 20 and a half events. In 2023 alone, we experienced 28 separate weather and climate disasters over that $1 billion mark. Mainly these events are also going to include, one of the big drivers of cost is here in the US is our category 4 and 5 hurricanes over the last 5 of the 7 years, including Harvey, Irma, Maria, Michael, Laura, Ida, and Ian. The US was spared a major hurricane impacting a major metropolitan area last year. As category 3, Adelia made landfall in a less populated Big Bend region of Florida. So it's important to keep in mind that these estimates don't include events that are less than 1 billion. So this is very conservative. And as we're saying, the number and cost of weather and climate disasters is increasing. This is due to a combination of events. And probably one of my big takeaways is just what we harp on over and over again with hazard mitigation planning is assessing risk. And risk is really the overlap of hazards and your community's vulnerability. So where the hazards overlap, you have exposure and you have a lack of resiliency and vulnerability, you're going to experience the most asset impacts, and that includes people, natural systems, cultural resources, as well as critical lifelines and economic drivers. I would point out that Virginia was affected by 82 of the 290 US billion disaster events that occurred between 1980 and 2020. And the costliest ever for Virginia was Superstorm Sandy in 2012, which caused severe coastal flooding and storm surges. And just to, we looked at the past, and I think it's interesting to look at what we have today. So right now, as of today, the US is currently facing 510 active wildfires. 56 million people are experiencing drought. Inland flooding is, there are over 7 million people that are under inland flooding, flash flooding alerts right now. There are 400,000 people that are under coastal flooding alerts at this moment. Extreme heat is affecting over 70.6 million people under heat alerts. So yeah, that's our timely right now. The FEMA Region 3 is responding to recent disasters, heavy rain events in northern Pennsylvania. We're participating in preliminary damage assessments up there, as well as recent flooding and tornado activity that happened this spring in West Virginia. But yeah, the hardest part about summarizing the region is it's so varied. So this is looking at global warming, projecting out days over 95 degrees. You can see that our region has a variety of geographies. Makes it a great place to live, but makes it difficult to summarize and pinpoint the exact, regional impacts. We'll go through this. This is just Virginia's, projected temperature change. I think that the speakers earlier hit this home. Here, I just want to mention again that, Art did a great job talking about the projected precipitation. There's substantial regional variation in the climate due to this region's diverse geographic elements, which include obviously the Appalachian Mountains, and the Blue Ridge Mountains, and the Atlantic coastal region, and everything that's in between. So, what does this mean? So we're seeing, more frequent and expensive disasters. A big part of this is our increase in exposure as well. So this is from the 5th National Climate Assessment. So, a great tool that if you haven't taken it away already, you might want to go look at after this, if you haven't looked at that already. But this, Virginia is a part of the Southeast region, according to the 5th National Climate Assessments split. But it holds true. Virginia has seen a big population increase, which is increasing, this one type of stressor. So when we look at one thing to keep in mind is the role of stressors in, our ability to be resilient and bounce back from these disasters. So stressors are conditions that make hazards more frequent or severe. So we have, climate stressors, which, is increasing the frequency and severity of extreme weather events. These can occur to natural or man-made human-caused climate change. We also have non-climate stressors, which include land cover, for instance, when natural vegetation is cleared and replaced with roads and buildings, and disruptions to natural drainage systems, and population growth, as well as public health, economics, and other social factors. So I want to let you all know about this additional tool. This is from the National Risk Index. This is showing the region split out by census tracts, looking at a number of variables to assess risk. Again, the risk is exposure and resiliency. So we look at the expected annual loss. There's an equation that is utilized here, as well as social vulnerability and community resilience. So we can see that, what we saw in the last presentation with sea level rise and hurricane events, we're also looking at some social vulnerability issues. We have the most risk around the Chesapeake Bay, and then going into West Virginia as well, due to their exposure to hazards and rain events, as well as, again, their social vulnerability. Both urban and rural areas are facing their own unique challenges. So, in the rural areas, you're seeing sometimes a decrease in population, lack of access to, jobs, declining population, older residents, difficulty accessing some areas. So these are areas that can be particularly vulnerable. And then in the cities, you see an accumulation of resources, and investment. So that also puts you at risk. So the last thing to keep in mind is, cascading impacts as well. So none of these disasters are happening in isolation. So when we're looking at precipitation, whether there's a decrease or increase, on top of that, looking at increased heat events, we can see cascading overlapping hazards, which are going to compound. So take, for example, drought is, particularly likely to be a part of a cascading hazard because it can occur over a large area. When it does rain, the soil is less able to absorb water. The drought can also increase the chances of wildfire, which will impact runoff as well. Across the Northeast, we're looking at infrastructure vulnerability. And here again, this is the intersection of the built environment and hazard risk. So whether that's the urban heat island effect, older infrastructure in the Northeast, including drainage and sewer systems, and flood and storm protection assets, as well as our transportation systems and power supply. A lot of those are nearing the end of their planned life. We talked about, the region's reliance on the oceans and coasts for, maritime heritage, economy, and ecological services. So those changing environmental conditions are going to shift and put pressure on the region. So lots of bad news. There is some good news. There are efforts to adapt to climate change. I'm happy to be a part of that with hazard mitigation planning. We are seeing many actions to achieve adaptation and mitigation goals, but there's certainly more work to go. FEMA itself, we are looking at pre-disaster and post-disaster grant opportunities. So we have disaster grant is after disaster, and then annual. These are programs that you can apply to pre-disaster. I would highlight the BRIC, Building Resilient Infrastructure in Communities. A sub grant in there is our direct technical assistance. We're working right now with the Hampton Roads Transit Authority, which is touching on service to socially vulnerable communities facing, severe challenges with climate change. And then we're happy to announce that we'll be working with some Virginia tribes and a rural community going forward next year as part of that program. We have some resources here. I'm happy to share the links. There's a ton of information out there that you can dig into. These slides will be shared with the links. So I won't spend too much time on that. A couple more resources, of course, the Fifth National Climate Assessment, the National Risk Index is where I pulled that map. And I guess one other point just to leave, we've been somewhat fortunate in the region to experience a little bit of a quiet time the last year or so. I mean, we haven't gone unscathed, but the challenge we see is that resiliency sometimes can take a back seat, and it's important that this does stay top of mind. Where our hurricane season has been relatively quiet, but we're not at the halfway mark quite yet. That's coming up on September 10th is the halfway. So we haven't gotten through the hurricane season, so keep these in mind. And with that, I'll end my presentation. Happy to answer any questions.
All right, thank you, Rodney. And I know we're kind of bumping into almost 2:30 here. We did have an opportunity. There was an opportunity that for folks who asked questions to have them answered by a variety of the speakers. Jessica, thank you for weighing in there on a number of resources and comments. So let me get back to, yes, the whole screen here of all the different speakers. Let's see here. People asked, one of the latest questions was asking about the impact of insurance rates going up. And of course, that is a factor that we're seeing. And a new, well, it has not quite hit us that insurance companies have moved out of our state and refuse to cover people, but that is a trend in Florida and other coastal areas. Another question spoke to, well, I actually, someone out of Maryland asked, do we have essentially a survey, a compendium of what cities and counties are doing best in our state, good, better, best. And I would say there's a lot of information that has been gathered on the coastal community side. It is, I don't know, how accessible it is to everyone, and maybe Jessica could speak to that, but we certainly could use a more comprehensive survey of where we're at on the inland, the non-coastal communities, cities, counties, regions, as far as where we're at in assembling data, where we are at in creating plans, and where we are at in good examples moving forward of how to address some of the climate adaptation needs. Jessica, do you want to speak to a minute here on what's available as far as examples across the coastal region?
Sure. So one place that I would point folks to, at least for state level plans, so there's been a whole lot of activity on plans, put it out there. We provide a table in Key Message 4 in the Northeast chapter of all of these state level plans that we were able to compile that were published prior to the literature cutoff for NCA 5. So we break those out by whether they were climate action plans, greenhouse gas reduction plans, or science assessments at the state level. The good news is that every state in the region has planning activity. At the state, the only one that does not have it at the state level is West Virginia, but even cities within West Virginia are acting. It's a little bit tougher, and it is a real focus of adaptation research right now as to what is effective adaptation. And what counts as effective is very, very dependent on what you and your community want to get out of it. And the other thing, and I just said this to a reporter earlier today, there's no one ring of climate adaptation. There's no one project that you can do that will go in and solve all of your problems. So an example that I like to give here is natural and nature-based solutions. We do a lot with that at ICAR. In fact, we receive an annual appropriation from the Commonwealth of Virginia for our ICAR to hire faculty to work on this in partnership with the Chesapeake Bay Foundation, specifically looking at natural and nature-based solutions. They're really, really great for things like water quality, for things like improving even health and access to the environment, for things like addressing sea level rise as it happens over decades and 5 years, 10 years, those kinds of periods. But going in and doing a marsh restoration might reduce the height of a storm surge, but it's not going to stop a 10-foot storm surge or a 15-foot storm surge. So when you think about adaptation, having your locality, your community develop suites of solutions instead of just saying, oh, this one project is going to fix everything is really, really important. This is also why it's really critical to have an adaptation plan or a resilience plan. Nobody wants to fund plans. You can now get some FEMA capacity building. Thank you, FEMA, funds for this. But it's really challenging sometimes to get these plans. But the important thing of having a plan is to be able to think community-wide and think holistically. It's not just about the risk reduction. It's about protecting your ecosystems in your community, your human health in your community, the economy of your community. And that means that you're going to need to have a range of projects. So things that we know are effective when doing those plans are making sure that the plans set goals, that the plans look community-wide, that the plans have a variety of different kinds of projects, not all just one kind of project, and that the plans make sure that they monitor over time whether or not these things are effective, because we're putting a lot of new solutions out there that are going to have to stand the test of time as the climate changes. So there's no one good answer for that, but we have a lot of good examples. And I always encourage folks to take a look at places that look a lot like where you live and see what's been successful based on that. Don't be Franklin County and be comparing yourself to Philadelphia. That's probably not very productive. But if you're Franklin County in Virginia and you want to take a look at Center County, Pennsylvania, then maybe that is a really good way for you to try to look, okay, what should we be doing? What can we be doing?
And I just want to thank the speakers again. Since we are a little short for time, we're going to kind of go forward on some end comments, but just to say, looking ahead, actually, our next Resiliency Academy, October 8th, it will have, we are going to focus on FEMA, and so Rodney will be back with more details and other speakers on the FEMA regulations, requirements, benefits, funding, tools, etc. And the further webinars, again, will speak to some of the work that, as in Art has mentioned, he is working with Mid-Atlantic RESA on the data and the CHAMPS tool, etc. So we're going to be focusing on those in further workshops, further Resiliency Academy series. We just wanted to also point out, as we're ending this, that you're invited, if you're interested in what's happening or what might happen or what you would like to see happen in the central and southwestern part of the state. September 25th, we're having a priority setting meeting, a very interactive facilitated meeting here on looking at priorities for climate solutions in the central southwestern part of Virginia. So that information is on our website, and we would love for folks to come and be involved with that. That is a free event, but you do need to register so we can have lunch for you. So we do want to, again, appreciate all the expertise that has been brought forward at this webinar, and just thanks again to our staff and our production team. And we will see you, we hope, at the next webinar. Please do take the very brief exit survey as we conclude for today. So thanks very much. Appreciate your attendance and involvement.